Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about how to find a largest element in an array and a smallest element in an array. Let us take an example. Just see here. I have an array like 3, 1, 4, 10, 9. So what is the largest element? I can say the largest element is 10. And what is the smallest element? I can say smallest element is 1. Okay. Now, how to find this largest and smallest number? Let's see. First approach we all know is just we can sort it, right? We all say just sort it. If I sort this, it will be 1, 3, 4, 9, 10. And take the first element as small and last element as large. That's all. This is what the first approach we all know. But since the time complexity is high, it is n square, right? We can do it in optimal state, right? We can do it in slightly optimal. Let us see. If I can traverse this whole array and keep on track of the smallest number, I can get the smallest number. And also, I will go to this array and keep on track of the largest number, I can get the largest value, that is the largest element, right? So let us take the same example. Now we want to find what? A largest number. Let us say we want to find the largest number. Let me take largest is equal to the first element of the array. Let me take it as 3. Fine. Now we are going to check the each element in the array, and if any element is greater than the largest, I want to update that largest with that greater element. Okay. Let me do it. First of all, 3. Whether 3 is greater than 3? No. Whether 1 is greater than 3? No. Whether 4 is greater than 3? Yes. Update it. Update it by 4. No. 10. Whether 10 is greater than 3? Sorry, 4? Yes. Update. No. Whether 9 is greater than 10? No. So don't update it. So what is my final result? It's 10. I got an answer. Yes. Same method. Just apply for smallest number. Let me write. Now we are going to find what? Smallest number. Smallest number. It's equal to, just take the first element. You can take any element in the array. It is just for the keep track of the smallest and largest element. Okay. Now whether this 3 is greater than 3? No. This 3 is smaller than 3? No. Whether this 1 is smaller than 3? Yes. Yes. Update it. Update it by 1. Whether this 4 is smaller? No. This 10, 9? No. Anything is not smaller than a 1. So it is my output. Yes. So this is what the logic for largest and smallest. Okay. What is the time complexity and how we are getting an efficient solution? How can we say it is an efficient solution? Because in this approach we are traversing only once the array. We are traversing only one time, right? So I can say the time complexity. The time complexity. What is the time complexity then? I can say it is O of n. Yes. So I can say my time complexity is what? O of n. Whether O of n is efficient or O of n square is efficient. O of n is efficient. Let me tell you one example if you don't understand. If I have 10,000 records, if I have 10,000 records, now I have to find the min and max, elements. Okay. Then by using this approach, this n square approach, I can say for this O of n square approach, I will get the value as 1, 2, 3, 4. Again 1, 2, 3, 4. This is my number of times the loop will run at the worst case. And then same question for O of n, it will run for 1, 2, 3, 4. Only n times. So you can see how much where differ between n and n square. Right? So this is why we want to use this approach. Let us see the code. See here. ARR is equal to 1, 2, 4, 7, 9. Okay. Here the array is sorted, but don't think that always the array is sorted. Sometimes the array may be sorted, but still sometimes the array not be sorted. Okay. However, the solution will must give the largest and the smallest element. Fine. Now, largest is equal to ARR of 0. For I in ARR, if largest is less than I can say largest is equal to I. Yes, yes, because if largest itself smaller than the current element, then I want to update the current element to largest, right? We can also put like this, it will be more clear. Current element is greater than largest. I want to update the largest as current element. Fine. So answer is 9. Now, same question, same thing. I have just small correction, like greater than. If small is of greater than the current element, then the current element should be the smaller, right? Update it. Okay. So the answer is 1. Okay. Till now we have seen the smallest and largest. Okay. Now we are going to step into the second largest element. What? Second largest element. Let us see a simple problem. This is an example. Just listen carefully. Let me say an array. Okay. 1 and then 4, 2, 2, 3, 5, 5. Okay, this is my array. What is my second largest? What is my second largest? I can say my second largest is, first largest is 5, second largest is 4. Because 5 is occurred how many times? 2 times. So don't take it. I want to take what? 4. This is my question. Now how to approach this problem? Okay, let us see. Let me sort it. The simple approach. All time we will do a simple approach like sorting for this. Okay. Now the array is sorted. Okay. Now array is sorted. Now we are going to traverse in a way from the last, whether this 5, sorry. Now this 5 is the first largest. It's the first largest. Whether this 5 is equal to the previous element. Yes. It's equal to the previous element, right? That means the next element. Yes. So this can also be my first. And then 4, whether it is equal to, no. So I can say it is a second largest. I want to find the second largest. So I will return it. Understand? So this is the basic logic. Now this basic logic will take the complexity of O of n square. But we want to do a more optimal solution. But how can we do the optimal solution? Let us take the same array. Let me explain. You can understand it. But listen carefully. See here. Now let me say two variables which are largest and second largest. Okay, and both variables are set to what? The initial value as 1, or you may set for infinity value, into max, into min, whatever you want. But for largest you want to set what? Into min. Okay, for smallest you have to set what? Into max. Let me show that approach also, because you want to know all approaches, right? Let me take here. In Python we will take what? Float of minus infinity, like this in Python. Okay, but in C++ we want to use like int min. Okay, because we are going to find the largest number. So we want to start with the minimum value, so that whenever a large number comes, okay, we can update it. That's why we are using it. Let me take it also float of infinity. Right, now just observe. I am taking the first element. Okay, minus. Okay, first element is 1. Whether this 1 is greater than L and greater than SL, it is greater than large element. Yes, it is greater than large element. So I want to update what? Largest element. Now largest element is what? 1. Okay, now taking the 4. Whether 4 is greater than largest element? Yes. Yes. Then I want to do what? Previous time I just updated this, but now I got an idea, I got a contradiction that I want to first assign to the second largest, then assign to the largest. So that take this one and first assign to the second largest. Take this one and first assign to the second largest, then update the value of largest as 4. You understand? Right? Because 1 is less than the 4, then 1 can be my second largest up to this part, right? Now again take 2. 2 is greater than largest number, no, but it is greater than the second largest. So I can say 2 can be my part of my answer up to this array, Yes, so update it. Can you understand? Initially we are putting like what? If largest is itself less than the current element, then I want to do what? Second largest is equal to largest, then largest is equal to the current value. This is what the first condition we have made. right? And then what is second condition? If second largest is greater than the current, but second largest is less than current, then I have to do what? This second largest is equal to current. So this is the second step I have done here, right? So this is my second step. These are two conditions we saw as of now. Okay. Let us take another. This 2. Again 2. 2 is greater than 4. No. 2 is greater than 2. No. Okay. 3. Whether 3 is greater than 4? No. But whether 3 is greater than 2? Yes. Updated. That's all. 5. Whether 5 is greater than 4? Yes. So what I have done here, if 5 is greater than 4, I have told you that take this 3 and update with 4 first. Then take this 4 and update with what? 5. Got it? Now again this 5. Now again, whether 5 is greater than 5? No. Whether 5 is greater than 4? Yes. Yes. But we don't want to update it, right? We don't want to update it. But still we will update it. But how can we make sure we don't want to update it? But just observe here, we are taking this 5, whether this 5 is greater than the largest? No. Whether 5 is greater than 5? No. Because largest 5, current is also 5. Then how come this will be get executed? Okay, fine. So that's why we are putting what? Greater than and not putting greater than or equal to. If I put greater or equal to, this will be updated as 5. Okay, so we want to put what? Greater than 5. Fine. So this is how we will find the largest and second largest. Fine. So what is the time complexity? What is time complexity? Time complexity is, I can say O of n. Yes, time complexity is O of n, because we are traversing only one time the whole this array. Right. Now let us see the code. Let's see here array. Then I am taking the min value. Okay, maximum min value. Sorry, minimum value for the integer. Okay. Now for I in ARR, if L is less than I, largest is less than I want to update my second largest is largest and then largest equal to I. But be careful, don't put here like equal to. If you put equal to, it will be gone wrong. Fine. Now L is greater than I and SL is less than I. That is, largest is greater than the current value, but current value is greater than what? Second largest. Then I have to update the second largest as current value. Then I want to print it. Okay. So my output is what? Second largest is 9 and second largest is 7. Then we take another 7 and 9. Okay. Another 7 and another 9. Now let me run this code. 7 and 9 is the answer. So we didn't get the 9 and 9. Okay, this is the first approach. Now I want to write as just a quick example 12779. Here, if I ask the first largest and second largest, then you have to return the first largest is 9 and also second largest is 9, because this is my first largest, right? And this is my second largest, because it is in the order of the sorted order, right? So how to print this? Just see here. I already told you, right? If I put equal to here, the whole meaning will change. Okay, the whole meaning changes like this problem. Okay, just put equal to here. Same this two condition, but just put a equal to here. Let me say here. See, if largest is greater than or equal to I, that's solved. Easy. Just equal to sign to change into another problem, right? Now let us see the second smallest element. Let me take second smallest element. So I have already told you the second largest number. So I don't want to give the explanation on the second smallest. Just see this code. I will explain it. Just understand. If you don't understand it, just comment below. I will do the separate video for this. Okay. ARR is equal to some array. Then I am setting the both to the maximum value in the integer. Then for I in ARR, if S is greater than I, if smallest is greater than I, that is current element is less than the first minimum, then I can say second minimum should be my smallest, then smallest should be my I. L if smallest is less than I already, but second smallest is greater than I want to update the second smallest is I. Okay, then largest and second largest. Okay, let me take the smallest and this is yes, we run it 1 and 2. Fine. So this is how we want to find an optimal solution for second largest and second smallest and a minimum and a maximum number in an array. Fine. Thank you.